We are now on Chapter 12, Part 2. We will start out on page 427, BitLocker. BitLocker performs drive encryption, hard drive encryption. So why do we use BitLocker? BitLocker protects against the theft of a hard drive. And it's also used to prevent the unauthorized booting of a computer, meaning you might have a server and you don't want just anybody to be able to walk up to it and turn it on. So you use BitLocker. BitLocker is used 2 reasons. 1, to protect against theft of the hard drive, and 2, to prevent against unauthorized booting of a computer. BitLocker has 3 operational modes: TPM, startup key, and startup pin. TPM stands for the Trusted Platform Module, and it is firmware on the motherboard which is used to store the decryption key. And the hard drive decryption key, as I just said, is stored on the TPM. So when you turn the computer on and it boots, the hard drive looks to the TPM, the key on the motherboard, to decrypt the hard drive so it can be used. But if somebody steals the hard drive and the hard drive is removed from the computer and put in another computer, it's not going to boot because it's looking for the TPM key, which is on the motherboard of the computer that the hard drive was stolen out of. So that's one reason that we use TPM. So if somebody steals the hard drive and moves it to another computer, it's not going to do them any good. The startup key is where we put the key used to decrypt the hard drive. And remember, you can't use the hard drive at all unless the hard drive has access to the decryption key. So we can store the key on a USB drive. And that way, when you turn the computer on, it looks to the USB drive to decrypt the hard drive. And if the USB drive is not there, then it won't boot. So this would be for a secure server. You don't want just anybody to boot it. So you take that USB drive and you keep it locked up. And when you do want that server to boot, you plug the USB drive in the server, turn it on, it'll boot because it'll decrypt the hard drive. You must insert the USB drive to start the computer, and it protects against unauthorized boot. The third method is what they call a startup PIN, personal identification number. I mean, you could call it a password, but they don't. And this is whereby when you turn on the computer, the user, network administrator, is required to enter a startup key. And if the user does not enter the startup key, the system won't boot because the startup key is necessary to decrypt the hard drive. Let's look at using group policy to configure BootLocker, and let us enable BootLocker in group policy. If we go into the group policy editor under computer configuration, administrative templates, Windows components, BitLocker drive encryption, under operational system drives, we select the option that says require authentication at startup. And when we select that and we click on the checkbox, it says allow BitLocker without a compatible TPM. Remember, TPM is a firmware on the motherboard, so we're not doing that example. We're doing the example, look to the right. If we click on this checkbox, then it will require the insertion of a USB drive containing the startup key such that it will boot. And if they don't have the startup key, it's not going to boot. That just enabled it in group policy. Now let's actually turn it on, which is going to encrypt the hard drive. So to do that, we go to System and Security, and at the bottom of the screen we see BitLocker Drive Encryption. and we want to encrypt the C drive, so I select Turn on BitLocker, and I click on Turn on BitLocker, and then it says, how do you want to do it? Use BitLocker without additional keys, require a PIN at every startup, or require a startup key, meaning USB drive. So I'm going to select require a startup key. And then it says save your startup key, insert a removable USB device, and select this device and click on save. And what that's going to do is it's going to save the key to the USB drive. And now it mentions this thing called a recovery key. A recovery key is different from the PIN or startup key. It is used to access your files and folders if a problem with the computer prevents you from doing so. So this is going to be the emergency recovery key. So I can save that anywhere, but I will save it to the USB drive. And I select that. And then it says, are you ready to encrypt this drive? You can keep working on the drive while it's being encrypted. Your performance will be affected because it takes a little while and it slows it down. And of course I typically select Run BitLocker System Check, and that way the system will check to ensure that BitLocker can read the recovery and encryption keys. So you just want to make sure that your keys are not encrypted before you start the process. Insert the USB memory device containing your saved recovery key. So I click on Continue, and then it encrypts the hard drive, which can take a few minutes to occur. BitLocker performs encryption of the hard drive. Now let's look at BitLocker to go, which is similar, but it performs encryption of USB drives. Don't we often save confidential data to USB drives and then put it in our pocket to take home to work on it? Well, you might lose that USB drive. So if we encrypt it, then if we use it, then if we lose the USB drive and anybody finds it, they're not going to have access to it. So let's look at BitLocker to go. To enable it, you go into the local group policy editor. It's pretty much the same place, but it's one line down under removable data drives, under BitLocker drive encryption, under Windows components, under administrative templates, under computer configuration. And I select control use of BitLocker on removable drives. And I select that, and I enable the policy, and I select the option that says allow users to apply BitLocker protection on removable data drives. Now I look at the description. Allow users to apply BitLocker protection on removable USB drives, and I click on OK. And then, of course, to enable it, that was just group policy. But now to actually perform the encryption process, I select my USB drive and I click on Turn on BitLocker. And then it says passwords, type in a password which you're going to use to access this USB drive. So I type in the password, followed by, and I retype the password, followed by OK, and it says, are you ready to encrypt this hard drive? You'll still be able to use it, but it takes a little while to encrypt the entire USB drive. And I click on Start Encrypting, and it goes through the process of encrypting the USB drive. And then to access the USB drive, you stick it in the USB drive, and when you do, you are prompted for the password. And you can't access that USB drive unless you know that password. BitLocker is used to encrypt hard drives, and BitLocker to go is used to encrypt removable USB drives. Page 480 discusses different types of remote network connections. Now, I think we've talked about VPN, Virtual Private Network, before, and remote desktop. We talked about that before, but we're going to look at something new called direct access. But first, let's review what's meant by VPN, Virtual Private Network, page 480. First, we'll look at what dial-up networking, and then we will see what virtual private networking is. Back in the good old days, before they had DSL and cable modem, if you wanted to connect to one of the servers at work at your house, you would have a modem, and that would allow you to connect to a modem at work. And you would connect over POTS, P-O-T-S, the plain old telephone system, and connect to a modem at work. That modem at work, or bank of modems, would connect to what they call a dial-in server, or they also call it a RAS, a remote access server, and then you'd go through that dial-in server to access any one of the many servers at work. So the RAS server, remote access server, was our single point of connection. Using a modem to dial up is the old way of going. Well, everybody's got DSL and cable modem these days. So now to access the server at work, typically you connect to your internet service provider. And typically your employer is also going to have a connection to an internet service provider, and they're all connected together over the internet. So you, the user, is connecting to the servers at work by going over the internet through the RAS server, and that allows you to connect to the servers at work to access confidential information. Here's the problem. The security risk is eavesdropping. The internet is a public network. It runs all over the place. So a bad guy with a protocol analyzer could tap in to a wire and eavesdrop and listen to your entire conversation. And when I say conversation, I mean data being sent from your computer over the wire to the network server. And the bad guy could steal passwords and credit card numbers. And we've talked about the threat of eavesdropping before in a protocol analyzer. Well, what we do is we encrypt the data. We encrypt the data on this end, so when it gets pushed over the internet, if a bad guy with a protocol analyzer is listening in, he can listen in all he wants. It's not going to do him any good because the data is encrypted. And this is called a virtual private network. Simply, the encryption of data as it's sent over the internet, they call that a virtual private network. Here's why they call it a virtual private network. It's not really a private network. It's a public network. It's the internet. You are sending confidential data over the internet, which is a public network, which typically you'll think is not a good idea. But if the data is encrypted, then you can send private data over the internet because it's encrypted. So that's why they call it a virtual private network. It's not really a private network. It's really a public network. But since it's encrypted, it acts like it is a private network. That's called a VPN. VPN is where we have a RAS server and a RAS client. And the RAS client could connect using old-fashioned modem, but most people these days use broadband, cable, and DSL. If we encrypt the data as it goes over the wire, then that connection is called a virtual private network. To create a virtual private network, we go to the Network and Sharing Center. We go to Control Panel, and we select Network and Internet, and we go to the Network and Sharing Center. And then if we look in the middle of the screen, it says set up a new connection or network. Set up a wireless broadband dial-up ad hoc, or VPN. That's the one we want. VPN connection. So I click on that, and it says choose a network connection, and I select connect to a workplace. So let's select a dial-up or a VPN connection. That's the one we want, VPN. I click on next. It says, how do you want to connect? Well, I want to use my existing internet connection, my DSL connection. So I say use my existing internet connection. And then I specify the IP address of the server that I am connecting to, the server at work. And I give it a name. I'll just call it VPN to connect to work, followed by next. And then I enter my username at work, followed by the password, and I enter the domain name, which for us would be CCBC. I click on Create. It says the connection is ready for use, and I can click on Connect Now. And then after I connect now, if I look at under my existing network connections, I can see VPN to CCBC, and I can connect to the VPN. And now we see connecting to VPN at CCBC. It is verifying the username and password. VPN Reconnect is whereby, I know this is a crazy example, but it's like it's your laptop, using your laptop and you're driving through the Baltimore Tunnel, right, under the Baltimore Harbor. And that way you would lose your internet connection. Well, I don't know who would be crazy enough to do that, but the point is, if you lose your internet connection, this feature called VPN Reconnect, it will try to reconnect if you lose your connection, so you don't have to do it yourself. So you go under this option under VPN Properties, and under the tab that says Security, under Advanced Properties button, under Mobility, when it says Network Outage Time, I select 30 minutes. So VPN Reconnect is whereby if I lose my connection, I don't have to manually reconnect myself. The system will try to reconnect. NAP stands for Network Access Protection. And if we look at the help screen for Network Access Protection, we see Network Access Protection, NAP, is a platform that network administrators can use to help protect the security of a network. When you connect to a corporate network that uses NAP, your computer is checked to make sure it has the required software and settings, and that software is up to date. In network access protection, here's the goal. Don't let a virus, which is on a user's PC, connect to the network, or don't let a virus-infected PCs connect to the network. So many people use their own computers and they dial into the network, and if they don't have a virus, or dial-in, we don't call it dial-in, they connect over a DSL, and if there's a virus on their computer, well, that's just a perfect way to get into the corporate network. So that's our risk. Somebody has a virus on his or her own laptop computer, connects to the corporate network, and it affects the corporate network. So network access protection evaluates a PC's health or a laptop's health. It verifies that it has currently updated antivirus software, and also that the security updates are currently updated, and that the firewall isn't updated. Network access protection only allows network access to healthy PCs. And what do you mean by healthy? It has antivirus software, it has all the latest security updates, and the firewall is enabled. If we look at the configuration screen on the server, of course, we don't really do this until we get to the server class, but we can configure based upon the operating system that the user is using, whether it's XP, Vista, or Windows 7, we can require that the workstation have the firewall enabled, that the antivirus application is not only enabled, but that it's up to date, that anti-spyware is installed, and it is up to date, and that all security patches are up to date. And if it's not, if a workstation tries to connect and is not up to date, what's going to happen? Well, it's going to be denied access. And that's the purpose of network access protection. It only allows healthy PCs access to the network. Now let's talk about remote desktop, and I think we talked about remote desktop before in a previous chapter. Remote desktop is where I need to work on a computer which is on the other side of the town, and I don't feel like getting in my car and driving over there. So from my computer, I connect to a remote computer, and then I can remotely configure that computer. In remote desktop, I click on my Start button and I select Remote Desktop Connection. Then I type in the IP address of the remote computer that I want to connect to, followed by the username, which is usually administrator, and the password, and it connects me to that remote computer. And now you can see in my window here it says remote desktop connection. So notice there are two start buttons. The start button on the far bottom left would start programs on my computer, but the start button in the remote desktop configuration window, if I click on that, then that's going to start programs on the remote computer. If I select Control Panel, then I can use Control Panel, and anything that I do in Control Panel here is actually going to be configuring the remote computer. Now, of course, the remote computer has to be turned on, and the cable's got to be plugged in. It has to have a good network interface card, and the network interface card drivers have to be loaded. So assuming you have a good connection, then you can connect to that remote computer, and then when you can create users, delete users, reset passwords, etc. That is remote desktop connection. Remote desktop gateway is really, it's the same thing. It's just for when you have a large number of users and a large number of servers. It's the same concept. So remote desktop gateway is where you allow remote users who have connected remotely to go through the remote desktop gateway server. And they use the remote desktop gateway server to connect to a Windows server which has remote desktop running on it. And that way the user here can run programs on this server. And this is also called VDI, Virtual Desktop Infrastructure. It's very much like remote desktop, except it allows many remote users to remotely connect and access virtual machines running on the remote desktop session host. And of course we install that when we get to the server class. We don't install it in this class. The difference between a virtual private network and a remote desktop gateway is this. With a virtual private network, it allows you to access files on the hard disk of the server at work. It allows you to access files which are on the hard disk of the server at work, but you're still running all programs on your own computer. Whereas remote desktop gateway, you are running the desktop on the server. You are running a virtual machine on the server. The difference is simply accessing the hard drive of the server versus running a remote desktop on the server. Direct access is introduced on page 488, and direct access is where the user is at a laptop computer, portable computer, and it allows the user to either access the network at work intra means it's within the organization, and access the corporate servers, but the user can also access internet servers, and it's a one-step process. Typically we think, well, you got to use VPN to access the corporate network, and then you have to perform a separate operation to connect to internet servers. If we look at Microsoft's website and description for direct access, give mobile users seamless access to corporate networks without a need to connect using the VPN. If we look at the description, working offline is easier than ever. Direct access on Windows 7 and Windows Server enables the productivity of mobile users by connecting them seamlessly and more securely to their corporate network anytime they have internet access without the need to VPN. In direct access, we can see that the user connecting over the internet will have transparent access. I should say transparent access. Direct access provides transparent access and secured access to the internet and the intranet without a VPN. That's direct access. To configure direct access, it's installed on a Windows server. And of course, we don't do that in this class, so we just look at the workstation end. So you use the group policy object to configure the clients to connect to the direct access server. Direct access. The user can access the corporate network from the internet, but the user does not have to initiate a VPN connection. What's the point? It's easier. It also supports encryption and IPv6, and another thing it does, it allows the network administrators to access direct access to apply updates to client computers using group policy. So it works the other way. That is to say, these computers here can be configured. Group policy can be pushed from the corporate network to the Windows Workstation client to push up updates or to install new programs. Chapter 12, Summary. In this chapter, we discussed wireless networking, Windows Mobility Center, multiple configuration settings, that is to say, multiple display settings, presentation settings, power configuration, offline files, and synchronization. We looked at BitLocker and BitLocker to go. We looked at virtual private network, network access protection, remote desktop gateway, and direct access. And this concludes Chapter 12. Thank you very much, and have a nice day.